we go to here, and we have 20 degrees of freedom. So there's 20. And you can see that even at the 0.15 mark, I'm too big. Or at the 0.1 mark, I'm too large here. So the probability is going to be more than 10%. If you look in your book, you can actually see there that it's going to be even bigger than 25%. And keep in mind that we can put into the calculator TCDF 0.349, comma E99, comma the number of degrees of freedom, which is 20. And we can see what that gives us. I'm actually going to do that with my calculator right now. And I know you can't see it, but maybe you can do the same thing and then test to see if you're punching it in correctly. And I come up with 36.5 or 0.365. So getting a statistic that's that extreme just by chance happens 36.5% of the time. Conclusion, we fail to reject H0 at the 0.05 significance level. Now, does that mean that the alternative hypothesis is false, that the scent doesn't help? No, it just means that this data doesn't prove it to us, and so we leave it there. So that's a matched pairs example. There is one other thing that I'd like to show you about it, and that's looking at some data. This is data that comes out of a couple of different kinds of software. Let's look at the one at the bottom first. And the tricky thing with data is figuring out what you need to be looking at. So I noticed that here is our t statistic. So if we were to see data like this, we would grab on to that number. Oh, we saw that one already, 0.349. And then we had a one-tailed statistic, this one right here. So we came up with this right here as our p-value. You know, one thing that you might see on the AP test is that they'll give you data like this, and you need to figure out that that's the p-value there. Notice that if it was a two-tailed, this right here would become our p-value, and you should notice that this one right here is 2 times our p-value, and that's because when you have two tails, you've got double the area to contend with. This one right here, I'm going to come to the one in the middle. This one's a little easier for us to deal with because they actually give us, there's your p-value right there. Okay, and everything else has been very, very neatly laid out for us. Okay, so that's matched pairs. Let's move on. Second piece, and this will be a quicker piece. This is going to take about 5 minutes. I want to talk about this word robust. And here's what robust means. If you look in Webster's dictionary, it's going to say robust refers to strength and it refers to good health. In mathematics, we refer to robust in this way. I want you to look right here. We say that a confidence interval or a significance test, the two things that we've been studying lately, we say that they're robust if the confidence level or the p-value, you know, the thing that you're coming up with, is not changed very much when the assumptions of the procedure are violated. And here's what we mean by the assumptions of the procedure. T procedures are assumed to be normal. So if they're not normal, how well do the T procedures work? That determines how robust they are. Well, the answer is they're moderately robust, But just like x bar and like s, t procedures are very strongly affected by outliers. And so we must be careful of data sets that have large outliers. Here's a problem that we did in the last assignment, daily calcium intake in milligrams. It was problem number 10. I don't know if you remember it, but there were two very clear outliers. And the problem asked us to calculate a confidence interval for the data and for the data's mean, and then to calculate another confidence interval once we had dropped the outliers. So with the outliers, here was our confidence interval. And then when we dropped the two outliers, we got this confidence interval right here. And the first thing we should note is that it moved the mean quite a bit. But the other thing that we should notice is that the outliers, when we removed them, it decreased the interval. And the interval is the thing that is controlled by t. Right? It's that t-score that tells you how wide the interval is going to be. That when we got rid of the outliers, we decreased the interval by an entire 100 milligrams, which is important. So the upshot is be careful of outliers whenever you are working with a t-statistic. It's the one place where it's not very robust. When can we use the t-statistic? Let's lay out a couple of restrictions. So if your sample size is smaller than 15, you should only use it if your population is normal. You know, if it looks like that. If it's bigger than 15, it's okay still to use the t-distribution, but only if your population looks close to normal. You know, if you have something like that, that's probably okay, but this would not be okay. Now, of course, here's the number we've been working with all along. If it's bigger than 40, then you can bank on it the mean of the distribution, or the distribution of the means being approximately normal, as long as it's as big as 40. Okay, so in that case, you can go ahead and use it. Here's a couple of scenarios. You'll notice here this is the count of first lightning flashes in hours after midnight in a particular region. And the one thing we would notice here immediately is that the middle bar has almost 25 pieces of data in it. So there's lots of data here. Here you could definitely use t and you'd be okay. Also notice that the data is pretty close to being symmetric. So it's not normal, but it's approximately normal. So we're good to go here. Here's one where we might run into a little more trouble. This is clearly skewed right. This, by the way, is a sample of the number of the length of words in Shakespeare's plays, and we'll assume it's a random sample. Now, in this case, we've got a plenty large n, because we can see once again this data right here, or this box has almost 25 data points in it. So n is large enough. N is bigger than 40. But if n were smaller than 40 here, then we could not use t. So because of this, t is okay. But if n were smaller than 40, then t would not be okay. Okay, here's your assignment. I want you to read the rest of 11.1. And then problem set 11b is going to be 29. Now 29 is a problem that is going to take a while. It's got a hypothesis test, and then it also has a confidence interval built in. 31 is also going to take a little while. You may cut 33 and then do 36.